right, so we're going to start today in the week 6 folder, free body diagram practice. I'm sure some of you guys have already have it open and have it going. So in there, this is a link to a Nearpod. So you're going to follow the link. It's a student-controlled Nearpod, meaning that you have control over it, not me. So I'm not going to be going through the slides one by one. I'm going to go through them, and you guys should follow along with me so you get the hang of it. But if you do get the hang of it, we'll move forward, and you guys can just do it yourself. So when you sign in, make sure you use your first and last name. That makes grading a lot easier for me because we do have some people with the same first name or last names, so it's hard for me to figure out which one's which sometimes. So you're gonna read through the slide and complete the activity. The drawing slides are what's gonna make up your grade. So in each one we have an example and a drawing, and then when you draw on it, we'll go from there. Now, I understand that we are not artists here, and it is very hard to do art with your finger on a keyboard or a touch screen. All you're going to be drawing are arrows. That's really all you're going to be drawing. So don't worry so much about how it looks, just that it's right. When you're done, I want you to leave a comment down here telling me you're done, so I know to go and check, because like I said, Nearpod doesn't give me an update when you guys submit things, but Schoology does. So when you submit this, I'll go through and I'll grade it. So go ahead and click on this link. All right. So what we've been talking about is forces, how they are applied to each other, how they interact with each other. And this is all under Newton's first law of motion. All right. Next year, when you guys have me for physical science, we're going to go more into all the laws, because Newton's laws of motion are actually pretty neat, and they apply everywhere. So we're going to dive deeper into them next year. But this is a little bit of foreshadowing, so the object will stay in motion in a straight line unless acted upon by an unbalanced force. That word should stick out to you because we've been talking about unbalanced forces. A force is a push or pull that will cause an object to speed up, slow down, or change direction. So that's what we're defining a force as. So an object will stay in motion until it's acted upon by a force. This also is true for an object that's staying still. For example, your computer right now is not just flying off your lap or your desk. It's going to stay still. If I left my cell phone on the table and I walked away and it came back 100 years later, it would still be there. So this is basically saying objects don't move unless they're forced. And objects will stay moving unless it comes in contact with something. Now you can probably think to yourself, well, then why is it when I throw a ball, it falls to the ground and stops? Because there's a lot of forces that are acting on that ball that you don't see, like gravity and friction. But if you were to throw a ball in outer space where there's no air resistance and there's no air friction because there's no air particles, there's no oxygen in the air in outer space, then that will go forever and ever and ever and ever and ever and ever and ever. All right. So we call these free body diagrams. So these are diagrams that show the direction and the size of the force being applied to it. I think I've shown you guys this picture before. Each one of these means something. So the normal force is the force that resists. The gravitational force. The applied force can be in any direction. This is something I need to point out to you. It's important. This says that the force is being applied to the right, meaning someone's pushing this box to the right. What friction is slowing it down. You could also have the force being applied to the left and the friction, so the opposite directions, just so you know that if it's going to the right, it's not always going to be the applied force, but you just need to make sure you read the problem carefully. All right, so here are the steps we're going to be following. One, you're going to pick an object to analyze because in the word problems that we're going to look at, there may be more than one object to look at. Two, we're going to draw a box to represent the object. So it's not, we're not always going to use the object. For example, there's a book in one of the questions. We're not going to use a book because, again, like I said, I'm not going to have you draw the object. So I think in one of them we're talking about a skydiver. You don't have to draw a guy skydiving. The box represents the object that we're talking about. So then you're going to draw an arrow to represent each force acting on an object. Now it's important to make sure you go through and you ask yourself, what forces are acting on this object? Because if if an object is only moving up and down, then there's no forces going on left and right. If an object is standing still, there are no forces. So make sure you guys understand that to read the problems carefully and make sure you understand the forces that are there. Then you're going to make an arrow that shows the direction and relative size of the force. So again, if there's a large force, it's going to be a big arrow. If it's a small force, it's going to be a small arrow. So here are all the forces that we're going to talk about. We've already gone over these, and some of them are pretty standard. So the applied force we talked about, it's going to be an F with little a. It's a force that an object places on something else. Friction is the contact force that opposes the motion when there's two surfaces touching. So think about sliding anything across your floor right now, that it would move farther if there was no friction, but it'll eventually come to a stop because of friction. This can also occur in the air. It's called air resistance. So if you've ever run really fast or been in a car and opened up a window, you can feel the air resistance with your hand in a car. You stick your hand out, move it up and down, you can feel the air resistance. So air resistance is friction, but in the air, essentially. The normal force is the contact force exerted by a surface. So just by two objects touching, there is a normal force, and it normally opposes gravity. The tension force is something when if you're talking about a string or a cable or a rope. And if you've ever hung anything from a string, it has tension. Tension is that force that if you stretch a rubber band really far and then like it snaps, that snap is the release of the tension. And then gravity is, something we know all too well. It's a force due to the attraction between two objects. And in all the ones that we're going to talk about, it's between the Earth and that object. Gravity will change based on where you're at and what you're doing. So if you're outside of the planet Earth. So if you're on the moon, if we were on Jupiter, gravity is different. All right, it just depends on where we're at. All right, so I'll walk you through this first problem. So the book is at rest on a table. Sounds boring, but there are forces acting on this. So it says draw the forces acting on the book. All right, so up here in the left corner, there is the force chart that I talked about earlier. So you can reference it when you're drawing. So the book is at rest on the table. All right, so we got to ask ourselves, what forces are being applied here? All right, so what I'm going to do is I'm going to choose red because that's the color of the book. And then over here, I'm going to make a box like we talked about. So ask yourself, what forces are acting on this object and in what direction? Start with the box. All right, this box represents the object we're talking about. So a book at rest on a table, all right, what forces are acting on the book? So we'll start with, is there any applied force? All right, so is there any object in here applying force on this to make this move? All right, what you should see here is the word at rest. At rest means there's no applied force. So if there's no applied force going this way or that way, then there's going to be no force in the right or left direction. All right, so if we know that there's no force in the right or left direction, you could also call it the X or Y direction, because if you think about, oh gosh, that was awful. All right, so also if you make mistakes, you can hit these undo arrows down here to lose the arrow. So they're also referred to as the X and Y direction. If you draw a coordinate plane, you know you have the Y direction here and then X direction there. So X is left to right, Y is up and down. So now we can think, all right, so what's keeping the book on the table? So it's not, the book isn't floating off into the air, just like your computer, your phone, your bed sheets, like it's not just floating away. So gravity is keeping this book on the table. So that is a force that we need to draw. So you're gonna do a downward arrow here. Oops. And you put F with a lowercase g for gravity, like that. So the force of gravity is pulling down on the book. But there's something that is keeping, there's a force that's keeping that book in place, because if you were to just hold the book in midair, the book would fall to the ground. So the other force that's acting on this is in the opposite direction. And that force is equal. So the force that resists gravity and keeps objects like flat on a table or a surface is the normal force. So you put an F and an N for normal. And this is what I'm looking for right here. Okay, I mean, so I'm not gonna, so even if I move on, it's not gonna change your screen. So this is like I said, it's a student-paced one. So you can control the pace in which you go through this. I'm just here to guide you through and teach you how to do it. And then you can apply it to the other ones. So again, if you look at the picture up here, you can reference your forces. So the contact force exerted by a surface on an object. This table is that surface, and it's exerting a force on the book, which is keeping it from falling through the table. There are no forces to the left or to the right because the book is not sliding in that direction. So remember, you have to ask yourself in every direction, what forces are being applied? Make sure when you're done, you hit submit. And then I'll move to the next slide. So, as you can see, this diagram, the normal gravitational forces are at work on the book. So gravity is trying to pull the book down to the ground, but the table is resisting that force of gravity and keeping everything still. The arrows should be the same because there's no mismatch in force. These are balanced forces because the book is not moving. It's crazy to think that like all this is going on just with the book sitting on the table. And again, you progress through the slides. So if you're following along with me, that's great. I'm just trying to show you how to do it. So since these horses are balanced, they cancel each other out and there's no motion. All right, problem 2. An egg is free falling from a nest in a tree. Neglect air resistance. That means there would normally be air resistance to this. But I'm telling you to ignore it. Draw a free body diagram to show the forces involved. So what forces are involved with this egg falling out of the tree? So we're just focusing on the egg right here. Okay. All right. So I'm going to start by drawing a box because this box represents the egg. So ask yourself in each direction. So is there anything moving the egg left to right? Okay. Read the question. An egg is free falling from a nest. Okay. So you should think that, okay, there's no wind blowing it. It's not, the problem doesn't say that there's a force applied. So there's no forces in the XY direction. I'm sorry, in the X direction, left to right. All right. Now it's falling. All right. So you are going to have a force pulling it down. And that force that pulls things down is gravity. So you draw a line. This is the line represents that force. And you do an F for force. And you do a little G to symbolize gravity. Now it says neglect air resistance here. Normally, I would say there would be an arrow pointing up. That would be the air resistance, but it's telling you right here, don't worry about it. So this is it. That's it. There are no more forces acting on it. There's no forces moving up. There's no forces moving left. There's no forces moving to the right. There's only one force moving down. So gravity is the only force acting on this egg, pulling it down. It's the only thing. If the egg was in the nest, it'd be just like the last problem where you have the force of gravity pulling it down, but the nest is the surface that is resisting that force and pushing it back up. So the only force is gravity. So you would draw something like this. All right. So it look like that. Make sure you hit submit when you're done. The forces are unbalanced, so the egg will accelerate down towards the ground. So when there's a force that's bigger in one direction than the other directions, that's when you have motion. So this is why the egg falls to the ground. The force of gravity is greater than all the other forces acting on it, so it'll move down. Motion only happens when you have unbalanced forces. All right, problem 3 is a flying squirrel. So in this one, it's consider the air resistance. A free body diagram, what would it look like for this squirrel? Now, a squirrel relies on air resistance so it doesn't die. If a regular squirrel jumped out of a tree, it would just plummet to its death and die. But flying squirrels have these big, like, wingsuit. If you've ever seen a wingsuit, they have them in like Fortnite and stuff where you jump out of the bus and you can glide to the ground. You're wearing a wingsuit. It takes advantage of the air resistance to slow you down so you don't die. So it says consider air resistance. All right, so this squirrel is only moving in one direction. So the squirrel is going down like that. So again, start with your box. Move mine down a little bit. Oops. All right, so in the last problem, we talked about a force that pulls things down. So there's a downward force happening here because obviously the squirrel is falling. What is that force called? Someone shout it out or put it in the chat. What's the force called that pulls things down? There you go. Gravity. Good one. All right, so this is put an F and a G. Now, it's telling you here to consider the air resistance. So air resistance is like friction in the air. It opposes the downward force. And again, if you wave your hand around in the air right now, you can feel the air resistance. So it's basically all the little atoms that are in the air push back on your hand or this squirrel's wings and slow it down. So it opposes, it goes against the force of gravity. So you can put something else here. So you're going to have a smaller arrow forcing up like this. Now, the reason it's a smaller arrow is because the squirrel is still falling to the ground, but it's just slower. And remember, you subtract the forces in opposite directions. So instead of the squirrel falling to the ground with all the gravitational force, it's being slowed down by the air. So you subtract the force of falling minus the air resistance, and that would give you the force that the squirrel falls at. But we're not going to get that complicated. So you would put another F, and it'd be the force of the air resistance. You just draw out air. A, I, like that. All right, how are we doing on this? We're halfway through. So we've done three as a class, and you'll do 3 on your own. I said, I'm asking you how you guys are doing on this because there's 6 questions, and we've done 3 as a class. Okay, I'll try to get through one more real quick. 1 second. Okay, if you submit it, you can go. If you go back, like this backward arrow, you can edit it again. All right. So problem 3, like I said, the air resistance and the gravity are the only ones acting on this squirrel. The gravity pulls him to the ground. The air resistance doesn't stop him. It's not balanced. It slows it down because it's not as great of a force. So this one, it says, a rightward force is applied to a book at rest on a desk in order to move it across the desk. So it says consider, that means there's going to be friction force, and neglect air resistance, meaning don't worry about it. So what forces are acting on this book? Okay, so first one up, is there anything moving in the up and down direction? So the book is not right. So the book is not flying off the desk. So you need to think that gravity is pulling it down and the normal force is opposing it. So gravity pulls it down. Oh boy. So this would be F. Why does my mouse keep doing that? And then the normal force. All right, but it does say a rightward force is applied. So that means there is a force moving the book to the right. All right, so from here, you're going to draw an arrow moving the book to the right. So it also says force is applied. All right, that should be a hint that you have an applied force here. So it's causing a push or a pull. So this force is applied. The last thing it says is to consider the frictional forces. So consider the friction forces here. So remember, friction, if you have something sliding across the desk, there's always going to be friction. All right, because that's the sound that it makes. When you slide something across, the sound you hear is the friction happening. So it's going to eventually bring this to a slow. So you're going to need to draw an arrow from the center here, moving back. Because it's opposing the force moving it forward. This is the force of friction. Let me see how I told you to label it. So right here. So it's F with a little f. So this is your body diagram. All right. The forces up and down are equal. So that's why the book stays still in the up and down direction. But it tells you that there is a rightward force applied in order to move the book. So since you have motion here, you have unbalanced forces. So that means that that's telling you that the forces moving the book across the desk are not balanced. So then this F for the applied force should be bigger than the F friction force because it's moving in this direction to the right. Now it tells you right here, make sure you remember to put friction in. Friction is applied. And to ignore air resistance. So then this would be correct. And as you can see on this one too, the arrow moving it to the right is greater than the arrow moving it to the left. Yes. So what happens is after, excuse me, after you get through it all and submit it, it makes a report for me. So I will get it, yeah. But it's not, normally it pops up on my screen if I'm presenting, but I'm not presenting. This is in, like, you have your own pace through this. All right. So there should be two more for you to try on your own. When you're done, just um, remember, leave a comment on that assignment, and that will tell me that I need to check your work on Nearpod. Yeah, I will. All right. So if you guys have any other questions, let me know and come to my office hours today at 11 if you're struggling with this. Okay? All right, but I know you guys got another class to go to, and so do I. So that's all I got for you guys today. Also, if you're struggling, I'll put it on the YouTube channel as well.